the point is that soil is matter out of place. In the case of even, quote, no clean flux, unquote, if it's in an amount that interferes with your product, it has to be removed. So cleaning is removing matter out of place. A lot of people talk about precision cleaning, and that's doing the process the same way, using the same process, maybe validating to a certain standard. But then there's critical cleaning, and that's doing the right cleaning at the right time for the right reasons, removing the right soil.
That's my guest, Barbara Koenigsberg, and her husband, Ed Koenigsberg, known in our industry as the cleaning lady and the rocket scientist. Next on Reliability Matters.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome to the program, Ed and Barbara. It's so nice to see you here in the studio.
It is lovely to be here in the studio.
And likewise.
Well, normally we are ships passing in the night. We see each other at symposiums and conferences and workshops and things like that, and we don't really get a time to sit and talk about business and about our industry. So it's nice that we don't have any of the distractions of a conference, and we're not running to the next meeting and all of that. So
absolutely not.
Thanks for being my guest. We've known each other for many years, as I said before, ships passing in the night. And I think your company, BFK Solutions, is celebrating an anniversary right now.
Well,
Actually, we celebrated our 25th last March.
Okay, so you're now on your 26th year.
So this will be 26 years.
Excellent.
And still going.
What does it take to run a small business for a quarter century or more? And I mean, those are choppy waters, right? Any small business.
Sure are.
Yeah.
Well, I might ask the same thing of you. I think it's a matter of having a real interest in the field, really wanting to help the people we work with, a real good sense of humor.
That's maybe one of the, and luck, right?
Yeah,
right.
A lot of luck.
Luck, sense of humor, and some skills.
Sense of humor, and enough distracting things so that we don't go crazy.
And since our work day it completely overlaps with our social day.
What social day?
Yeah.
What life? It's all right. It's all lovely.
Right.
Yeah.
So you just just reevaluate what social means, right?
Yes.
Oh
right.
yeah, we incorporate.
No, we incorporate it.
Yeah.
And so we do try to get somewhat of a work life.
Well, what's the saying? If you enjoy your work, you never work a day in your life.
That's right.
Isn't that right?
That's
so
right.
You guys are affectionately known as the cleaning lady and the rocket scientist. Tell me. Let's start with rocket scientist. Tell me what that. I think I know what that means. Are you an astrophysicist?
So, I'm a physicist. I got my both my undergraduate and graduate degrees in physics, and for the first while, quite a long while after getting my doctorate, I worked in an aerospace company doing R&D on instruments that were used for navigation purposes. Many of them were satellite instruments. So
was that pre-GPS?
This was quite pre-GPS, yeah.
Wow. Yeah. So a little, probably military accessed
some
technology?
Of it, good part of it was military, but also
Marine, maybe?
Commercial aviation.
Okay.
Planes need to know which direction they're going and how fast they're going.
That's helpful.
And so that's what the instruments were doing, and whether it was a commercial airliner flying coast to coast or a military plane.
Well, planes fly even today. it amazes me that planes fly VOR to VOR to VOR to VOR. If you look at a path across the country, it's not necessarily the shortest distance. It's a section. It's a whole bunch of straight lines connecting dots across the country.
Yes. Yes.
Which amazes me that we have the technology today to go point to point.
We actually have had the technology for quite some time. It's of course gotten much better as we do go along. But I can remember back even in the 1970s, which sort of dates me a bit.
Oh, you remember farther back than
I
that,
do,
dear.
but they were touting the fact that they had I believe it was a 747 that took off from Los Angeles and flew to New York, strictly wire to wire. You know, the pilots never touched the controls, and that was quite a few years ago.
Yeah. Well, we've made a lot of progress since then, hopefully.
Of course, they were the only one in the sky at that time because nobody else would let them.
So you don't go by your doctorate title. We don't call you Dr. Ed.
So I don't ignore it, but no, it's not.
See, if I had a doctorate, I think I would require my grandkids to call me doctor. I mean, I would fly a flag.
Yeah.
But
We do.
Yeah.
And
No.
you graduated, you have your undergraduate degree from Massachusetts Institute of Technology.
MIT.
Yes.
Yes. So he really is an official.
He's not a bragger. He's not a
No,
bragger.
he isn't. He really isn't.
Okay, the cleaning lady. Now
Yeah.
that just conjures up all sorts of images. Up from a woman walking down a hallway with a mop to what you do in your professional life. So how did that label get applied to you, Barbara?
It sort of evolved. I had gotten into aerospace. My boss came up to me. I was working in the analytical lab. I'm a biologist and had moved from biology to aerospace, same company as Ed was at the time. And I was totally bored because, you engineers make the same mistakes every few weeks and want analytical proof that the same thing happened again. And it was kind of boring. So my boss said, we think we may need to get rid of some of our Freon, some of our CFCs. And at the time, most companies used tanker trucks full of it that would just pull up, a lot of them just big, huge trucks that you see on the highway. And he said, the guys really that are in charge of it, there's a whole committee, but none of the guys want to talk to each other or evaluating any new processes or go to meetings or change the process. Do you think you could do it? I bet you could. You could do it in your spare time and it won't take much of your time, dear. And I never let the man forget that he said dear. Within a week, the head of this multi-site conglomerate company was running down the hallway saying, "Where's our Freon lady?" And I didn't know what to do. I was brand new to the field. I barely knew what Freon was, but learned real quickly. And I realized that getting beyond the HVAC systems, more of the interesting issues were involved in cleaning. And so the whole field of cleaning grew up around me. So that's it. The concept of Freon lady morphed into cleaning lady.
Well, especially since Freon's illegal now. I mean, they haven't made that in a number of years.
At least
that version.
They've phased it out of production. My understanding is that, and I don't anybody do this, but if you can find Freon,
that's my understanding.
You could still use it. But
that was a really good teaching moment of supply chain and supply and demand. You could teach that in business schools when the solvents were phased out over a 10-year period from 89 to 99, as you recall. The the government said after 99, I think they accelerated it a little bit. You can't make them anymore, but if you have them, you can use them. So I watched. We used to sell vapor degreasers back in the day, and we used to get Freon TMS for free from DuPont, right?
Sure.
For free. I think we paid a $20 drum deposit. The drum was worth more than the content.
Oh, it was
at the time. And then
it was very little. It was what, 50 cents a pound
it
or
was
something
really,
like that.
really
It was
cheap.
nothing.
It was really
Yeah.
cheap. And
Of course, Girl Scout cookies were $1 or $2 a box. So
What? 50 cents.
well, if the government ever bans Girl Scout cookies, I'm moving to Switzerland or something.
Yeah.
Yeah, me
because
too.
I
I'm
can't
right
live without
there
my
with
Girl
you.
Scout cookie.
I'm
And
right
this is
there
Girl
with
Scout cookie time. If you're listening to this,
I know.
Yes.
I know.
sometime in February or March, you'll know this is Girl
we
Scout
get
cookie
assaulted
time. Yes.
In a
every
good
few
way,
days.
In a
at
good
the-
way.
It's not an assault, it's an
It's
opportunity.
entrepreneurs.
Yes.
Yes.
Little entrepreneurs. Let's look at it that way. Yes.
So I remember the
But
we
I
stopped
can't say no. So.
Neither can I, and I don't want to.
Yeah.
That's a guilty habit. So I remember the price. We stopped getting it for free toward the last several years, and then the price of a 55-gallon barrel went from $150, whatever it was when it was freely traded, to $10,000 or more if you had it. It was definitely supply demand, and so yeah, my understanding is if you still have it, you can probably use it, but
Yeah.
or give it to the Smithsonian or something. So there's a line on your website that just I thought was rather comical, and I'm
Only
sure
one? Okay.
well one that I'm going to talk about.
Okay.
And there's probably a story behind it, and what I'm after is the story behind it. And it says, "We break for sobbing engineers." So my question is, when they call a consultant in, well, first of all, let me give you my definition of consultant, and it's going to sound like a negative, but it's not.
No, it's all right.
My definition of a consultant is someone you hire to tell you the time, and the first thing the consultant does is borrow your watch.
Oh,
right?
yeah.
And I say that not that consultants
We
aren't worth it, but
And if it's a nice watch, maybe we keep
maybe
the
you keep.
watch.
Well,
Yeah.
there are those types of consultants, but the point being, the answers are right there in front of them, and you are simply pointing out where the answers are buried. They can't see them. Maybe forest from the trees, maybe something like that. So when people call you guys, finally, when they call in a consultant, it means they've exhausted all the resources. They've tested the saying that the definition of insanity is trying the same thing over and over again and expecting a different result.
Yeah.
How deep do people go before you get the call? How much do you have to repair before you can just bring them back to neutral and then solve their problem?
There's an
Yeah.
It varies all over the place. From time to time, we even hear from designers who call us with a new design, and they're going to take it into production, and they want to have some understanding of what it's going to take to actually put the product together. Because the software will talk about materials, it'll talk about spacing of materials, but it won't discuss things like subtle changes in materials compatibility, like residue that's entrapped in tight spaces. So we get everything from people who are really being proactive to people who are absolutely panicked. Maybe yield has gone down, and it's hard to say. Maybe a regulatory agency is at their door, and our approach to that, if it's something like the Food and Drug Administration, we tell them, well, the way we're going to manage this is we're going to look at the problem, and we're going to be very transparent, and we're going to fix the problem and demonstrate that we fixed it. So it's all over the place. Mm-hmm. Sure, perhaps you've run into it that do people always respect cleaning? Do they think of it first? Do you want to?
No, I mean, frankly, cleaning is frequently something that they relegate to the third shift, and it almost becomes a punishment for a bad job performance review.
Sure, or it's a new hire. They start them out handling the cleaning process, and maybe they don't give them any instructions. And you were asking about sobbing engineers. We say that because if there is a real emergency, we triage a bit. We're a small company, and if somebody really is hurting, if there's a danger, if there's a dangerous situation going on with safety issues, if there's a issue with product reliability, we're right there, and we'll call our other clients and say, look, something has come up. Can we take this first? And that's what we mean by it. They're not always sobbing.
Right. But they...
Or, you know, and it's variable. Sometimes people will say, well, this is not an emergency. When would you like us to come out? How about in 3 days? But it's not an emergency. Okay. Do you want us to talk about cleaning? No, just take a look around. And then all of a sudden it's, could you prepare a program specifically for us in a day and a half? So,
well, it's funny. I when I speak, you've probably heard me say this before, and I'm sure I apologize to my audience who's already heard this ad nauseum, but it really is, I think, a good point, and that is today society values cleanliness in our social fabric. So we go into hotels, we demand that the hotels are clean, the sheets have to be changed daily, you know, and towels have to be changed daily, even though we don't do that at home. Our restaurants, we both live in Southern California. We all live in Southern California. So we're used to the letter grades on the restaurant. You know, you never want to go out for seafood. You know, that's
letter C.
The letter C.
Yes.
You know, our hospital rooms are clean to the point of sterility. We put antibacterial things on our hands. You know, at this moment in time, half our people are wearing face masks. If you go to an airport, everyone's wearing face masks because of the coronavirus fear. We are obsessed with cleanliness, except in one specific area, maybe more, but the one that I'm aware of is electronics. We just think that, well, wait a minute, this one chemical that we apply to our board, we're being told, or we were told in 1989, that chemical leaves a benign residue. So, hooray, we don't have to clean anymore. So we really don't value cleanliness in all parts of our life. And what the irony is we spend half our day putting not moisturizers, but antibacterial things on our hands and wearing masks and doing all this and eating in restaurants that have an A grade rather than a B or a C. Yet the electronics around us that are keeping us safe, that are transporting us, that are keeping us alive in medical cases, we don't value cleanliness in those things largely. So that is the weakest link. It's always the weakest link.
Sure. And Mike, I think maybe I'm glad you brought up that issue. You brought up a couple of important issues. Could we take a step back and talk about what cleaning means in a general sense? Because, we're generalists. I sure got started with electronics, attempting to get the military to allow no clean flux. In fact, they used to require that in some cases, that we remove organic acid flux using Freon, which was quite charming. We had to set up a flushing station, and after a while, the flux itself would lose interest. It would be carried off. It had nothing to do with solvency.
It wasn't solubilizing it. It was just pushing it off.
No, it was just boring the stuff to tears, and it left.
Like a flash flood removes trees. The trees aren't solubilizing in the water. They're just getting pushed off.
They're just getting carried off down the stream. But I want to let's discuss cleaning in a general sense, because I know for you the whole world is electronics, and you're right.
There's more than that?
No, there's no more than that. If you have electronics, isn't it all okay? I think it is.
Yeah.
So soil is matter out of place. In electronics, the solder paste, whatever you're using, is matter out of place.
After you've used it.
You've had a good use. Yes, you're right.
Yes, it's there for a reason. It's there.
It served its time.
It's actually providing a cleaning process.
Sure.
In its use, but then once that particular part of it has been used, it then reverts to being unneeded and unwanted.
And so, no clean flux. As I gnash my teeth whenever I use the word, everybody used to say it should be low residue flux.
Thank you, Barbara.
Yeah.
You're very welcome, Mike.
We're all singing off the same hymn.
La la. No clean flux doesn't mean residue free.
This is probably the first song our audience has heard.
There could be more.
It's Reliability Matters, the musical.
Yes. And we are only having coffee here, honest.
Yeah.
It's just caffeine.
What's in that coffee?
Oh, just some almond milk all good. But the point is that soil is matter out of place. In the case of even, quote, no clean flux, unquote, if it's in an amount that interferes with your product, it has to be removed. So cleaning is removing matter out of place. A lot of people talk about precision cleaning, and that's doing the process the same way, using the same process, maybe validating to a certain standard. But then there's critical cleaning, and that's doing the right cleaning at the right time for the right reasons, removing the right soil. And one thing that we've noticed is that electronics manufacturers, assemblers, are now beginning to realize that there's more soil than flux residue.
Right. One thing that you've heard me say before is when we stopped removing flux, we stopped removing everything.
That's right.
And we talked about don't call it a no clean flux, call it a low residue flux, right?
Yeah.
That's more appropriate. The other, if we're going to start renaming things, the other thing I'd suggest we rename is quit calling it a defluxing process. Call it a cleaning process.
Ooh, what a concept.
Because flux is one of the soils. It's the only soil we intentionally applied to the assembly.
Right.
But there are board fab residues, there are component fab residues, there are nasty little human residues, and there are other assembly-associated residues. And then we put flux on the top of all that. And if someone tells us correctly or incorrectly, largely correctly, that the residues in the flux are benign at best, then we think there's no reason to remove everything else. And you're right, the totality, if we were to put everything on a pie chart, probably the smallest little sliver of pie would be the flux residue, assuming it was no clean. And the larger components of that pie would be all the other usual suspect residues.
Yes.
Yeah, and if I could talk a little bit about those residues. People in electronics have always been concentrating entirely, in many cases, on whether those residues are ionic. That is, do they conduct electricity? And if so, that then becomes, they can create shorts between components that shouldn't have connections between them.
It takes away the dielectric property of the laminate, right?
Right. But what they don't realize is that even residues that are not conductive at DC are conductive at high frequencies. If you have a dielectric and it between your components, and you're trying to run a high frequency circuit, that you've created a capacitor.
That's right. Yeah, it's not just an electrochemical migration concern.
Right.
On certain high frequencies and high voltages, you have other issues that affect.
That's right.
It doesn't necessarily create a dead short, but it does change the operation of the board, of the assembly.
Yes.
Yeah. On your website, you talk about
You
Street
actually
Smarts.
read the
That was me. That was, so if you got one hit on your website over the last month, that was me.
That was you. Oh, that was you, huh? Ah.
And this may have come from your newsletter. I don't remember, but
Oh, yeah.
you talk about getting your street smarts here, right? And when I think of street smarts, those are always the things the schools don't teach you. There's formal education, and then there's street smarts. So what's the difference between, with regard to cleaning on any application, what's the difference between what people think they know through education and what you're teaching them through street smarts?
So it's a combination of theory and experience. I have a background in biology and biochemistry, so I'm not surprised when things are not exactly as stated in the colorful brochures. Living systems have many factors. if you design, say, a blood test, you have to account for differences in individuals and differences in what they may have ingested or whatever's going on in disease states, things like that. We have almost that complex a situation with, I'll bring it back to electronics assemblies, because I know the whole world is electronics. And as you you're really, when you're building, when you have not just the board, but the entire assembly, you have a host of different materials that can interact during the process. And you then have complexity that you won't see in theory. So it's the same thing as a designer may say, theoretically, this assembly should be really easy to put together. I've calculated everything. And then there are the people in the actual facility, in the assembly facility, especially the techs, laughing and saying, "Oh, this guy doesn't know what he's talking about." Well, everybody's right. It's a matter of communication and really making sure that you actually test things.
Right.
So as a biologist, I did a lot of testing. As the cleaning lady, I find myself doing a lot of testing. More so, frankly, I would say, than aerospace does in designing things. I would look at the way you would test things and I would say, really? And it all works? Well, yeah. I mean, it's nav systems are relatively easy. Putting together cleaning processes has a lot more chemistry, a lot more physics, a lot more, dare I say, abnormal psychology, because there are a lot of variables involved.
That's true. What does it mean to become a curator of your suppliers? That's something you recommend your customers do, is curate their suppliers.
That was one of our postings.
Yes.
You've read them, Mike.
Am I passing the test?
You are.
So, but that struck out at me. It's in our world, we believe that, we become the buyer of our customer. We choose our customers as much as our customers choose us, right? Because we need to be compatible. We need to make sure that our solution is a match to their problem. So when you say become a curator of your supplier, are you suggesting that there are some sketchy suppliers out there? There are some good suppliers out there?
Yeah.
What does that mean?
It means what you said. It also means that some suppliers are more experienced with your requirements and the requirements of your customers. Let's take it to the biomedical field. We've worked on combination devices, so that goes way beyond electronics. It has a bio part and a mechanical part. You cannot know all about all of the suppliers. I remember one device had bio and non-bio aspects probably from 6 of the continents. And in some cases, even the supplier didn't know everything that they did. They may have started with animals, and it was a matter of just keeping those animals healthy. So, and when you get into let's even take away the bio part of it, do you know how many metalworking fluids there are? I sure don't. Do you know? No. And then when you go and machine with them, they turn into something else. And then the supplier may or may not clean off those machining fluids appropriately. Then they may plate, they may anodize. Who the heck knows what they do? If you have polymeric materials, the way you treat them can vary quite a bit. So it's a matter not of understanding everything soup to nuts, but having suppliers that you trust. And that's what I mean curating. They may not tell you everything that they do. They may not choose to, they may not be able to, but you can at least get them to say, if you change anything, give us warning.
That's a wise bit of advice right there. When someone changes something midstream, that happens to us. We have suppliers. We're an equipment supplier, and one of the things we use is software. We use Windows type software environment. Sure. When Microsoft, they drive us crazy because Microsoft will come up with a service pack update. They change something. They don't really let us know, and all of a sudden, our machines don't work.
Yeah.
Gee, we
and
could do a
break
whole
it.
program on Microsoft, couldn't we? Well,
Yeah.
We could, which is
But-
why I'm sitting in front of a Mac. But that
yeah, me
To our-
too. I wouldn't. Yeah.
I shouldn't say that because I've just alienated probably 75% of our audience. But
Oh,
we talk about in my world and your world, and probably when people think of cleaning, they think of solubilizing substances, right? Just because that's our
Yes.
relationship with cleaning, unless we have a professional relationship with cleaning, really involves solubilizing the soils when we clean the dishes and when we wash our clothes and when we clean the floor. We're solubilizing soils. But there's a whole nother aspect of non-solubilizable. I make up words.
Ooh, I love it.
Right.
It's a good.
Yes.
and
works.
And I think my friend and colleague Doug Pauls
Yes.
from
Yes.
Collins Aerospace.
Oh, sure.
I'm not sure if he coined it or if he just used it, but I certainly heard it first from him, which was FOD, foreign object debris.
Yes,
there's
that's-
FOD on boards. I would have
Yeah.
come up with probably a cruder name for it, but FOD.
Yeah, that seems to encompass everything to pigeon poop to submicron particles.
Exactly.
Yeah.
Exactly.
And it is a widely used term.
That's right. And it's probably the first time our audience has heard pigeon poop and singing on the same episode. That's pretty cool.
Just wait.
We're groundbreaking. So, Boeing today, just to throw everything into context, Boeing today, with all the troubles they're having with the 737 MAX, well beyond the original grounding issue, discovered they're trying to get their planes ready to fly again. They have a lot of them on the ground, and they discovered that there's quite a bit of FOD, foreign object debris, in their fuel tanks.
Yes.
From the manufacturing process. Well, that could be deadly.
Yes.
Right.
So, now they have to go through and inspect all the planes and remove all the FOD and all
And
that
the
stuff.
fact that they've been sitting on the ground so long even adds to the problem.
Probably so. Well, in your world, Ed, with building rockets and rocket scientists, FOD means something. If you're going to put something into space, there is no FOD allowed. There is, right, because those become bullets. in the sky.
Rework is rather difficult.
In space, yes.
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 Yeah.
It's
Yeah.
quite, yes,
Yeah.
the
You
repair
don't-
person charges.
Yeah.
So it has to go up clean, not just clean from a solubilization standpoint, but clean from a FOD standpoint. There cannot be any debris on many of those on pretty much the whole thing. And if you're going to do any plating or any coating or any anodizing or any surface treatment, that surface needs to be, conformal coating in the board world.
Right.
That surface needs to be completely free of all ionic and non-ionic solubilizable material and foreign object debris, right? Otherwise, bad things happen.
Yes.
Well, I mean, the point is, you say completely free. There's no such thing.
That's a good point.
Really, or you cannot verify that it's really complete. So you have to set limits and determine, okay, at what point are you safely beyond a risk level?
That is a perfect segue, Ed. Thank you. And the question that many people ask themselves and ask us and ask you guys in particular is how clean is clean enough, right? And
Right.
and IPC recently, within the last year or so,
Yes.
came up with the perfect answer. The answer used to be how clean is clean? 1.56 micrograms of sodium equivalent per centimeter
Yes.
squared on a board,
Yes.
which was bogus from the start. And, that was arbitrarily chosen. And it didn't have the answer was not in context with, what's the cost of failure? Where's it go? What's the climactic and use environment? It was just one number serves all.
I thought that number came from Mount Olympus, no?
It may have. I think
Yeah.
it was the 11th commandment that Moses brought down
Oh, that
on
could
the
be.
tablet.
Yeah,
When the tablet broke, they never put that one back together. But it might as well have been. So the new standard, the new amendment 1 to section 8 of the new J standard, basically, without using these two words, the basic answer to how clean is clean enough is it depends. That
Yes.
was a wise answer. So now no one cares what number you get as long as you have objective evidence to show that that number is not problematic to the reliability of the assembly. So someone has to put their board in an oven under bias and temperature and humidity and do an SIR test on it. So it's a coupon. It's not really the board. And then, figure out, did the board fail after 1,000 hours at heat and humidity under bias? And if it didn't, what was the SIR value? And then test the board in a roast tester and go, what was the roast test value? And keep roast testing, and until you have a spike in that number, you're cool. You can just keep shipping product.
Yeah.
I don't have a problem. My only problem with that whole thing is, you're not really testing, other than in roast testing, you're testing the board that you're shipping to a customer. In the SIR world, you're not testing the board that's going to the customer. You're testing a board similar to the type that's going to the customer, because it's a coupon. It's a witness board.
Sure.
So, I'd rather be able to test the actual board that's going to the customer, but SIR doesn't allow that. So, but I think it's a huge improvement. So in your world, if it's outside of electronics, because I know you do a wide swath of cleaning consulting.
Sure.
How do you answer how clean is clean enough? Or maybe even better asked, what questions do you ask your customer so that you could tell them how clean is clean enough?
Oh, boy. That's a great question. I could use an example of a group where the customer was not so much concerned about ionic residue. The customer said you can build it to have a very low ionic residue. However, we are concerned about particulate level. How did this client find out? Well, the client was able to communicate with the customer. Is it always easy to communicate with a customer? Is it always easy?
No. But the more you can communicate with your customer, the more you can become partners in a sense of knowledge of what you're doing. It doesn't mean that you need to know every detail about your supplier or every detail about your customer, but you do need to be able to communicate so that they can tell you what's on their mind, what are they worried about, and so that you can worry about that also.
And that's where it becomes a combination of art and science. Sometimes and experience and really attempting to be tactful. I grew up in the family retail business, in the clothing business, pretty much during the era of Mrs. Maisel, maybe a little bit later.
Love that show, by the way.
Love that show, too. Yeah, she's an inspiration. But my dad
went to Bryn Mawr. Too.
Yes, we both went to Bryn Mawr. We did. Different times, but my dad used to practice his sales talks on me. And he would always say, Barbara, the customer is always right. And then he would pause and he would say, but you always have to listen to the customer, because you have to listen to what they say they want and what they really need and what they mean, and put that all together. And that's really tough. No matter what the standard is, and I've been involved in too much standard development, even though it's a fun hobby, it really comes down to the agreement between the electronics assembler and the customer who's purchasing that assembly.
Mm-hmm. That's a good answer. So where do you see, since most of our listeners are in the electronic assembly industry, where do you see our industry going over the next 5 to 10 years? Right now we're at the cusp of IoT and automotive electrification, and I think we're at the early stages of all that, and it's just going to get bigger. Where do you see the industry going in the next 5 years, and how, if any specific way, will that impact reliability, the need to clean, the need not to clean, whatever?
Well, one thing I'm curious about, actually, in terms of the future, is the role of additive manufacturing, where you, in theory, you can build your entire circuit by printing it. And that would obviate the need for solder fluxes, because they would be part of the depositing of the material on the board. It also then lends itself not to just planar assemblies, but to three-dimensional assemblies. And you can pack an awful lot more stuff in a cube than you can on a side of the cube.
I was at a conference in Hawaii last week.
Oh, poor baby.
Yeah, feel sorry for me. I sacrificed, took one for the team. And I was speaking to a student that was giving a paper. I think he was from Germany. He was giving a paper on printing electronics and printing the traces and using conductive ink, which I've heard of before.
Yes.
And the last time I heard of that, it was an interesting idea. It has a lot of applications toward textiles and things like that.
Sure.
But I asked him, I said, the last I heard about that, which was many years ago, one of the troubling issues is the bonding, the adhesion of the component to the trace. Right now we use solder, and solder acts as a great electrical conductor and a really good glue because you have this intermetallic, bond. How have you overcome that? And he looked at me and goes, "Oh, we haven't." I said, "So
that's right.
If I have a printed device and I drop it on the floor, do the components fall off?" He goes, "Yeah."
Yeah.
So just don't drop it. So in that world, it didn't seem to have gone too far to resolve the issues. But I think additive manufacturing certainly is very interesting. There's more and more talks on that now.
Well, there's more talks on it, and you can actually print organs and print skin. It's limited. You need complex printers, and you don't buy the ink. It's a different kind of situation.
You can't go to Staples and buy
no.
hard ink.
I've looked.
Not there, right?
Haven't seen it. Nope. It's behind the big bottles, big jars of pretzels.
There you go.
But I think one of the challenges is what is termed post-printing processing or post-printing manufacturing. And so I think what we will see is more complex designs, designers putting not just 20 pounds of stuff in a 10-pound bag, not just 100 pounds of stuff in a 10-pound bag, but maybe 500 pounds of stuff in a 1-pound bag. And that is going to make cleaning much more important, and not just doing more and not just spraying a solvent or spraying a water-based cleaner on it, but being strategic, being critical about it.
Yeah. I share that. I share that view.
Yes. Would you like to talk about the product quality cleaning workshop?
That was next on my list. So thank you for that segue.
Practically psychic.
So there is a product quality cleaning workshop, which is held at Sam Houston State University in Huntsville, Texas.
Yes.
I was looking at that. Was that an error? Not Alabama.
No.
Huntsville, Texas. So don't fly to Alabama.
Right.
And
be careful when you're there. It's the prison center of Texas.
They have the largest school, I think, a very fine school of criminal justice.
Don't pick up hitchhikers in that area. That's what I'm hearing.
We've walked there. We enjoy working with the group in Huntsville, Texas.
Yeah.
So you either, if you commit a heinous crime, you either go serve time in jail or join the cleaning industry. Those are your choices.
No. They have Sam Houston State University is a very nice sized school. It's the kind of school that I think you would want your children or grandchildren to go to because they appear to like teaching there. And so but that's another
How'd you get involved in that? How'd you get involved with this product? Is this your workshop that you're getting them to do, or are they recruiting you?
It is a collaboration. The PQCW is a collaboration between BFK Solutions, that's
us.
me and Ed, yeah, and the Cleaning Research Group, which is headed up by Dr. Darren Williams,
who will be a guest in a couple of weeks on this podcast.
Yes. And so, hello, Darren.
Yeah.
We have wanted to do a workshop for quite a few years because, as you've pointed out on a number of occasions, as we've noticed, nobody teaches cleaning in school. And it's kind of a hybrid. And many professors are afraid of something practical and are reluctant to get into a hybrid sort of situation. Just as there are silos in industry, there are silos in universities. Darren has experience in academia and in industry, and he's perfectly happy to educate cleaning ladies of whatever gender.
So he's the cleaning man of that university.
He is the professor.
The professor.
Ed is also a professor.
So it's the professor, the rocket scientist, and the cleaning lady.
All we need is Marianne and Ginger, and we could have our own
Yes.
island.
That's
Correct.
pretty much.
There we go.
Much.
Right.
Although it's not an island. So let's talk about product quality cleaning workshop. Suffice it to say that we decided to work together a while back. And what's glorious about PQCW is that we don't just teach, but we get everybody into the lab and we have cleaning exercises. So you get to mix the chemicals. You get to look at particle levels. We use fingerprint powder as part of our particle.
Which is a very fine powder.
You go to your roots. It's fine. You work with what you have, and we have demonstrations. And it's wonderful because we have people who have a scientific background, and who are also very practical. It's great for people in industry. It's great for people who provide cleaning agents, provide cleaning equipment. It's wonderful for the electronics industry because we will have to get into more and more techniques for cleaning the assemblies. And many of them will be demonstrated at the workshop. It is May 13th to 14th. We all get together. We stay. There are nice hotels on campus or near the campus, and we feed you.
No one's staying in the frat house then.
No, nope, and no one's had to call the police on us so far.
So far, this year could be different.
This year could be different.
This could be Ed gone wild.
This could be Ed gone absolutely. Yep.
But we do, we provide meals and a social gathering at the end of the day.
I've seen pictures of prior events, and it does look, it does look fun.
It's fun. People enjoy it. So what you learn sticks better. That's kind of the
right. Yeah, it gets through the barrier. And if someone is interested in attending or getting more information on the product quality cleaning workshop, May 13th through 14th at Sam Houston State University in Huntsville, Texas, featuring Ed and Barbara and Dr. Darren Williams. Darren Williams. I'm sorry.
Dr. Darren Williams.
Darren Williams. How do they learn more?
Do I have the link memorized? Probably not.
Well, I'll put it in the show notes. So if you're listening,
that would be good. It's www something or other. Yeah.
Right.
Now,
or they can probably go to bfksolutions.com.
They can go to bfksolutions.com.
We have a page on our website. And
you can go to PQC. If you Google PQCW and Sam Houston State University.
Yeah, you can find it that way, but I'll put it in the show notes.
Yeah.
So
put it in the show notes. We have a launch page. Darren's got a launch page. It's gonna be really good. It surpassed my expectations. We'd wanted to do this for maybe 20 years.
Yeah.
And Darren stepped up to the plate.
Dreams come true.
But also, since we're somewhat restricted in space because everybody that comes, we have to be able to accommodate in the chem labs for the hands-on demonstrations.
So seating is limited.
So seating is definitely limited. We can't just say, we'll go to a larger lecture hall.
Right.
Plus,
it's a finite space.
We have lecture halls that are large enough, but we don't have the...
We don't want to go to too large a lecture
and then
hall.
That's
we want it to be hands-on and
we want it to be
absolutely. We want to have people have time to actually. That's one of the things that we've learned from the workshop that we ran 2 years ago. We needed a little more time in the lab for these exercises, so they really have time to do something.
Yes, and time and
then time to talk about them.
Yes.
And speaking
absolutely.
of time, we're starting to run out of that. So let me ask you one question I wanted to get in. How are the twins doing? And
The
by that, to our
twins.
audience, I mean your
The
handbook for
books,
critical
the
cleaning,
handbook for critical
Right.
cleaning,
which you affectionately refer to as the twins.
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 It's
They're
two-
fraternal, 2 volumes.
Two giant volumes. These aren't little booklets. These are
No, they're each about
books.
500 pages.
Yeah, they're doing well. They're hardcover, paperback. There's a digital copy, and most people, I think, actually like to underline, so they get the.
I'm waiting for the Audible version where you speak
We could-
the 1,000 pages.
Okay. Would you
Okay.
like to do that with us?
Yeah.
That doesn't.
No.
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 No, probably not.
They are available either in a hardbound edition, a paper-bound edition, or you can
Electronic
you
edition.
can get
Ele-
digital.
Digital.
And you can find those on Amazon.
You can find them on CRC on Amazon.
The publisher is CRC Press,
So that's probably the cheapest way to get it.
and
So CRC Press or Amazon, if you want to spend a
Yeah.
buck or
Right.
two more.
And-
the handbook for critical cleaning,
And
and
it
this is like a volume. This is the like revision 2 or something.
It
Right?
This is
It's
Rev 2.
yeah, the
Yes.
first one we did, right around the turn of the century,
Millennium, yeah.
and then 10 years later we came out with edition 2.
So there are 2 volumes or 2 books. Volume 1 talks about the chemicals and the equipment and putting it together. Then Volume 2 gets more process specific, gets into how you select the equipment, gets into specific sectors. We have several chapters on electronics assembly, including one that talks about the fact that it's more than ionic. What we also have medical, we have metal, we have aerospace, optics, whole bunch of different ones and what we tried to do was get in people with different viewpoints. So we did some of the overview chapters, and experts in the field wrote their own chapters, and we frankly edited it and curated a bit. So and it was fun. It was a huge challenge, and I am so thankful to everyone who became involved in it.
Excellent.
And what we found, one of the things that when we do this, even within our ordinary consulting, when we go in to a company, we like to take experiences that we've had, not necessarily with their product or their type of product, but maybe from a totally different area. So if we're in a medical device, we'll take something that we learned from, say, an experience in aerospace or food processing. It's the cross-pollination of how different people have addressed this, because everybody, or at least almost all industries, all products, encounter cleaning at some point in their process.
That's true. Yes, absolutely. For different reasons. Or let me put it this way, probably for a similar reason, for reliability, but different types of soils, different types of challenges, different types of impingement issues, all this kind of stuff.
There are commonalities and there are distinct differences, and I've been enjoying learning about it over the last. Well, I've been doing this independently for 26 years, and I was in aerospace for 9 years before that. So you can do a lot if you start working when you're about 10 or 12 years old.
Yeah,
That's right.
Really,
We all were child labor.
child labor,
Yes.
absolutely, yeah.
I mean, we are continually learning, because
Uh,
recently we've been learning a lot about a technique that for agitation to dislodge soils,
And
it's not ultrasonics and it's not spray,
but that's
but it sort of encompasses some of the reasons why you would want to have a high pressure spray or jiggle things
Yeah,
off.
we used to build
using
machines that used they were cleaning under immersion, and we used eductors,
Yes.
which was basically like an air horn underwater.
Yeah.
So
Yes.
the pump would push some water through the center of this cone, and it created a Venturi effect. And it sucked for every 1 gallon per minute that our pump pushed through, 10 gallons a minute of water would get sucked into it.
Yeah.
And it looked like it was a violent boiling tank, although it wasn't hot or wasn't
Right.
that hot.
Well, you can also achieve that effect by changing the pressure, and that will change the boiling point.
Sure.
You can alternate
in a
that.
vacuum,
Yeah, or a part, not complete, but
partial vacuum.
Partial
Yeah.
vacuum. And yes, so I think that all of the challenges, that all of the aggravation is going to lead to many more opportunities and a much better result. I think that for electronics assemblers, understanding what came before and what the source of their components, and then understanding what the assembly is going to have to do afterward. And that means talking to the customer and asking them and listening. And that's tough. I'm still learning that. I think we're in for great times.
Yeah, that's one thing that I've learned. If someone asks me, how clean does this need to be? I ask them, you got a half hour? Sit down. I need to ask you a dozen questions.
At least.
Just to get a ballpark of how clean the assembly should be. Well, this has been an absolutely terrific time.
I have had fun.
I hope you have.
Wait a minute.
Yes.
Time up already?
I know. It's been
Oh, my God.
55 minutes and counting. So
Lord.
we're doing good. So to the marvelous Mrs. Koenigsberg, a.k.a. the cleaning lady,
Yes.
and the rocket scientist, Ed Koenigsberg, thank you both for joining me. We've tried to get this interview on the books for a good 8 months. And between your schedule and my schedule, we haven't been able to do it. So I'm really glad we were able to nail this down today.
We volunteered to meet you in Hawaii, but
I waited. I brought my microphone and you didn't show up.
Well, we could do a follow-up on the beach, perhaps.
We could certainly do that. During a luau.
During the luau.
Drinking Mai Tais.
Yeah, I was going to say a refreshing beverage.
A refreshing beverage.
I like that, yeah.
Well, thank you both very much. You are a huge source of information on all things cleaning. Thank you. And thanks for being my guest. And we will run into each other at future symposiums and conferences and workshops and all that stuff. I look forward to rubbing shoulders with you again in the near future. And good luck on your product quality cleaning workshop coming up in May.
Oh, it's going to be fun. It's going to be awesome.
I look forward to hearing good reports. Send some pictures.
Okay.
Yeah.
Thanks again, guys.
Bye-bye. Thank you.
Well, that's another episode. Thanks for listening to the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on iTunes, Spotify, iHeartRadio, or wherever you get your podcast. Reliability Matters and other reliability-based podcasts are available at Circuit Assembly's PCB Chat at pcbchat.com and at Ascendo Reliability at reliability.fm. Thanks for your comments. Please keep them coming. Send comments and episode suggestions to Mike at mikeconrad.com. That's Conrad with a K. Until next time, thanks for listening and keep doing it right.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.